we get started, we just have a couple housekeeping rules here. Just to get it started, I'm Fernanda Krupek, and I'm an assistant professor in urban food systems at Ohio State University, and I'm joined here by my colleagues at Ohio State, Jim Ippolito, Asmita Marumkar, and Mambi Racker. So we'll be facilitating today's discussion. So the topic is tips and tricks for improving urban soil health. And just a little bit of housekeeping rules here today. Today's program offers continuing education units, and we'll be providing certification information at the end of the program. I also want to emphasize, don't be shy to ask questions. We would like this webinar to be as interactive as possible, right? So please submit your questions at any time using the Q&A chat feature at the bottom of your screen. And also, if you would like to email your questions, you can reach out to Asmita Marumkar here with her email display at the screen. And before we introduce our speakers, we actually would like to learn a little bit about who is with us today. So if you can please share where you're from, right? Your city and state, and you can put in the chat so we'll be able to learn from each other's here where you are attending today's webinar. Okay, so let's go ahead and get it started. We have two great speakers with us today, Dr. Sam Wortman and Maggie Rivera. And we're going to start with Maggie's presentation and then Sam Wortman. So I'm going to introduce Maggie here first. Maggie is an agriculture and natural resources educator from Ohio State University in Summit County. And before working in Summit County, she spent 4 years as educator in Cuyahoga County. And prior to working with OSU Extension, Maggie directed the Farm Business and Program for Refugee Response at Ohio City Farm in Cleveland. Maggie earned a bachelor's degree in biology at John Carroll University with an environmental studies concentration, and also an MS in community-based food systems from Michigan State University in 2010. I had a chance to work alongside Maggie in some urban agriculture extension related projects here in Ohio, and we are very thankful for Maggie joining us today, sharing about urban soil health. So I will stop sharing and hand it over to you, Maggie.
All right, thank you, and thanks for having me today. Let me share my screen and just make sure that's working here. All right, can everyone see the correct view?
Yes.
All right. All right, yeah, so like Fernanda said, my name is Maggie. Just in case you're not familiar with the Ohio counties, so Cuyahoga County is where Cleveland is, and I currently work in Summit County where the big metropolitan area is Akron, so both in Northeast Ohio. So yeah, I have my experience working with doing urban agriculture. And just for reference, this picture behind me is the Ohio City Farm. So you can see at the bottom is a lot of the bed rows of where we would grow vegetables, and you can see the city skyline in the background. So I have that experience growing, but also about 8 years of extension work under my belt now too. So, all right, let me see if I can advance my slides here. So in general, what I wanted to share with you in my short time today is just my experience working with urban clientele in testing urban soils. So I have a lot of experience with that. And in terms of tips and tricks, right? Testing our soil is got to be up there as like number one, right? In terms of improving productivity, soil structure, all that good stuff. So that's what I'm going to spend my time. So I'm going to show you some slides that I share with urban clientele who are interested in growing. And I'm hoping that you can gain from that as well as maybe, you know, some some ways to communicate with your clientele as well. But first, just to introduce urban soils, because they are very different from some of our soils we work with in our suburban or rural areas. So the biggest difference is that they have lots of use history, right? So sometimes they say they have past lives, right? So they have lots of use history. We have land that was once farmland, you know, was developed into homes or housing. Then maybe that the housing was demolished and now is kind of seeking a new life. And that's kind of the most common scenario we see. But there's lots of other potentials, right? You know, urban areas are dense with businesses, and those businesses can include anything from gas stations to dry cleaners, which I'll mention later. But our common challenges in urban areas and with our urban soils are number one, compaction. You know, we see this often, very often. Um, we also occasionally see contamination issues. And then overall, those two big challenges causes kind of a loss of biological life in diversity and biomass. So because the soil is not suitable for a lot of our soil macros and micros, and because it's been pulverized and manufactured over time, you know, we lose a lot of that biomass and that biological life. Okay, so just to set it up too, so why do we seek such a difficult growing proposition, you may wonder, especially if you're kind of coming from the rural uh, perspective, where in some areas we have beautiful soil to grow in. Um, for cities, it's a plentiful resource. So in some of our cities, I should say, it's a plentiful resource. So particularly in our deindustrialized cities like Cleveland, Akron, but also, you know, Pittsburgh, Detroit, cities all throughout the Great Lakes. There's plentiful vacant lots that can be used for production. So cities and counties are in the position where they actually want to see this land used for some purpose. So often they're very supportive of use for gardens of these vacant lots. And with restoration, it can be a really incredible resource. You know, it can be a source of food production, environmental resilience, and community beautification. So we certainly want to see that. But there can be, just from the urban clientele in general, people are coming from a lot of different perspectives in terms of what they would like to grow and why. So we have, you know, a great amount of turf grass, right? We have a lot of people growing their lawns and wanting them to look nice. We have a lot of folks who are interested due to food security issues and just community resilience, wanting to grow food, right, on vacant lots. We have folks who are interested in landscape gardening, ornamentals, natives, and we have folks who do that at home, but also in community, so at schools, faith-based organizations as well, and everything in between. I just want to kind of start with this myth because a lot of times when we're talking about urban soils, there is this kind of myth that all urban soils are contaminated. So I really just want to bust that myth right up front. The truth is that it's important to screen soils as a precaution because we just know with housing before 1978 is what I heard, but recently I saw before 1960. So you know, what somewhere in that range, it's important to screen those, especially in our region, because we used lead-based paint, right? And lead-based paint had a legacy of contaminating our housing, but also the soil around our housing. So it's important to screen, but with my experience working with community gardens, so when I worked in Cuyahoga County in Cleveland, the city of Cleveland supported a really huge community gardening program with over 200 community gardens throughout the city. And we were responsible for testing those soils initially, but then every 5 years. So you can imagine how many soil tests and samples that I've taken, over 5 years, working there in Cleveland with that program. Uh, More than not, we those soil tests came back clean. So from a perspective of running a lot of these tests and seeing the results that come back, the great majority come back clean, ready to use those soils. But sometimes you will get a result that indicates that there's contamination. So um, we have to then decide what to do. I also just wanted to shout out that there is a National Lead Poisoning Prevention Week that is in October, from October 25 to 31 in 2026. And I find that a really great opportunity to communicate with the community about the importance of screening your soils for lead. Okay. Another thing I tell the clientele, because a lot of our urban clientele are just not familiar with soil testing. So many folks come and they think, I want to test my soil to find out if there's anything bad in my soil. But I have to kind of explain the process is that we have to know what we're looking for to actually test for it, right? When we're working with a soil lab, we have to request what to look for. So just to tell people that a soil test is not a crystal ball, and we have to think about what we might be looking for. There are these broad sets of environmental, reviews that you can do, and sometimes organizations will go for those, especially if children are involved or vulnerable populations. But those are incredibly costly, and often they're not needed. So for the most part, if we can kind of narrow down what we need to look for, what we're at risk of having in the soil, we can avoid that high cost. I just wanted to share this resource. And I apologize, I didn't put anything in a QR code, but I'm happy to share any of these links that are in my presentation today. But this is the EPA's Brownfields and Urban Agriculture publication. And this is just a very helpful table just to see what kind of all the different possibilities of contamination, right? We talk a lot about heavy metals because that is the number one kind of contamination issue that we're on the lookout, especially as it relates to human health. But there are a lot of other things that could be looked for and could be a contamination issue depending on the site history. All right, so let's talk a little bit about sampling in the city. So I shared this photo in one of my initial slides, but this is pretty representative of a vacant lot in a deindustrialized city, right? You have houses on either side, but within it, there's a few lots that are unused. So a lot of times people are kind of staring at this and thinking, okay, so I want to take a soil test. How might I go about that? And with all of the talk about site history, the first place I want people to start is if the city or the county has information about that parcel number that they have. So these are two examples, again, in Northeast Ohio of Akron's kind of, or Summit County's map, and Cleveland or Cuyahoga County's map. But this is a great source of information because you can go back within the tax records and kind of see what that land was attached to in the past. So a lot of times you can confirm that at one point there was a house, there were houses here, and that can be useful information. You can also determine too if there was a business there, right? And sometimes the name of the business might be able to lead you towards what that type of land use was. Okay, so this is an incredibly important place to start. But those websites also give you this aerial overview with the parcels defined. So, when you're looking at it, you can see that those are the two houses, and there's actually 4 parcels, 4 city lots in that space we were just looking at. So this is really helpful to this overview because, again, if you can determine that it was houses that were there at one point and they were demolished after they had fallen into disrepair, then you can kind of get the sense of where the buildings probably were, right? So we have all of our houses pretty much lined up at the front of the lot, and then the back of the lot may have had a garage, but mostly yard and plants. Um, I always also try to encourage gardeners if they're starting to treat their soil evenly because then they can test it down the road as well. All right, so then I encourage people then to kind of think about what lab they're going to send their sample to. Um, and with this, with urban soils and especially looking for heavy metal contamination, um, we have our Ohio line fact sheet, which gives you a nice list of labs within the Ohio area and surrounding areas. We often use Penn State and University of Massachusetts as places. They just have really strong soil labs that have been around for a long time. Very easy for the public to use them as well. Um, and more recently, we have at OSU, our soil, water, and environmental lab has started to test for heavy metal contamination as well. So I like to give everyone all of these options because the prices range quite a bit. And at the risk of sending our OSU lab too much business at one time, I will say that OSU probably has the best price out there right now. So I think it's somewhere at $35 or so, and they test for heavy metals, lead, arsenic, and cadmium. So it's a really good price for the test, and it's a high quality test. We use that X-ray X-ray fluorescence test, so um, really good high quality test as well. Okay, so I want people to though to think about what lab they're going to uh, send their sample to before they even take their sample, because then they have that next step in mind. So again, then I tell people go back to your overview. You basically have now separated the site into two separate areas, right? A lot of us know about soil variability from our maybe precision agriculture, right? That's been more of a topic now that we have precision equipment that can actually fertilize to, a very great degree. So we have two different areas, right? And we know that they're going to be quite different. So we want to sample them separately, right? So now we know we're going to send in two samples to the soil lab that we've chosen, and we can kind of move forward here. The soil sampling equipment is pretty similar to any other soil sampling equipment. The only thing that I will mention is that because of the highly compacted soils we often are dealing with in the urban area, a lot of times our typical soil probes might not be tough enough to get into our urban soils. So especially if the tip of the soil probe is not sharpened, it's not going to be able to do that. So if you are purchasing equipment, be careful. I've made this mistake myself. But a lot of times your full size shovel is going to be your best tool to kind of carve out a soil core and lift it out in that soil. Another thing I recommend for people is that if you can't get a full size shovel in the ground, that's a big red flag and an indication that you might want to choose a different site to grow at. So if that is that level of compaction where you can't get a full size shovel in, not even 2 to 4 inches, then again, that's indicating there might be an issue. And also, you can't determine if the dust that's kicking up from that area is not whether it's going to be a human health risk or not. All right, if you can't test it, you don't know if it's safe. All right, we're back to our zones. So again, we've cut it into 2 zones. And then I just walk people through really quickly and say, you need to get those 10 subsamples to send off, just to give them that idea. Because again, our urban clientele usually have never taken a soil sample. So just give them that visual idea. Common scenarios I see in Northeast Ohio, we often see high phosphorus and potassium, usually kind of off the charts. We high or low organic matter, depending on how long people have been gardening there. We typically see a higher soil pH than some of our surrounding suburban and rural areas. And then, of course, we might have that elevated lead or other heavy metals. Okay. And the last thing I'll leave you with is that when we get the soil test back, of course, as a A&R educator, I work with people to interpret those results. But I think it's really important to tell people up front that if we find elevated lead, it's not a death sentence for your garden dream, right? That if there's moderate levels of lead, there might be some remediation strategies we can work with to continue to have a garden at that site. Because I never want people to be in the situation where they don't want to test their soil because they're worried that they might not be able to go forward. Of course, if the contamination is to a certain degree, if it's highly elevated, then we will have to recommend that they choose a completely different site and cannot go forward in a safe way. So this is just a slide showing all these different soil management strategies if there is elevated lead. So there are a lot of options out there. So that's what I have to share. Here's my information, but I'm sure we can share that afterwards as well. So thanks for your time, and that's what I have for you all today.
Thank you, Maggie. Appreciate it. And yeah, please continue adding your questions. We'll go back to them after Sam's presentation. And so yeah, so now we have our second speaker, Sam Wortman. Sam is an associate professor in the Department of Agronomy and Horticulture at the University of Nebraska, Lincoln, where he leads the Grow Local Innovation Lab. Sam's team designs, creates, and also tests methods, ideas, and products to support local specialty crop growers and also improve the social, economic, and environmental sustainability of local food systems. Some of the current research projects that Sam's team is leading are focused on strategies for reducing and reusing plastic mulch film in vegetable and strawberry crops. Also, development of evaluation of biodegradable alternatives to plastic using cover crops as living molds to reduce insects, wind damage, and weed competition, and also improving soil health in urban gardens. A fun fact, I had the chance to learn more about Sam's great work during my time as a graduate student in Nebraska. And actually, I used to live right across the street from the research farm where some of Sam's research projects were based. So it was always fascinating to me to see the different projects being implemented and also get the chance to taste some of the vegetables harvested at the farm. So Sam, thank you for joining us today, and I'll hand it over to you.
Very good. Thanks, Fernanda. This might be your apartment building right here, huh? In the top of this image.
Exactly, yes.
Very good. All right. Well, I appreciate the invitation today to share a little bit about what we called the Nebraska Urban Soil Health Initiative, NUSHI for short. And this was a partnership with Nebraska NRCS. And we looked at the combined effects of cover crops, no-till, compost, and biochar on soil health and vegetable crops. All right, so Maggie set this up pretty well, but urban soils are not typically high quality soils. And, just by coincidence, since this is an OSU webinar, I've got an OSU reference here, Beniston and Lall 2012, lots of good urban soil work by that group. And so we've got some soil physical properties, right? Compaction, decreased water infiltration. Maggie talked about the potential for heavy metal contamination, and we can also find alkaline pH, and then sometimes low organic matter soils, and that decreased microbial activity, diversity, and biomass. So, to better facilitate crop production, soil quality can be improved in urban soils through intensive management. And so, this table is from that same paper. And I just, pulled out, we've got in that first column the different possible constraints. So things like drainage and compaction. And then from the literature in this review, they looked at what are some of the management practices that we know can help alleviate some of those constraints. And so in green here, I've got some boxes of some common themes, right? So cover cropping, adding organic matter, so that might be things like compost applications. Um, One paper, it looks like Hargreaves et al. 2008 recommended biochar application. A couple different recommendations for cover crops. We've got reduced tillage, and then a suggestion to mulch or cover soil to deal with that lead and heavy metal issue, and then even nitrogen fixing cover crops to deal with low nutrient content. Okay, so we've got some options. And so we kind of use this as some of our rationale for starting this initiative. So intensive soil conservation practices are just not as commonly studied in urban garden soils. We've made a lot of headway in these practices, and Fernanda did some of this work as part of her PhD at Nebraska, looking at things like cover crops and no-till in rural agricultural soils and looking at how that influences ecosystem services. And so, we know that these practices can contribute to the long-term economic sustainability and resilience of farms. But again, just not a lot of data for how these practices contribute to our urban soils. And it's, certainly easy to concede that how we individually manage our urban gardens probably has a relatively small impact on overall environmental impacts and sustainability, right? I've got maybe 200 square feet of kind of tillable garden space in my backyard and, try to use soil health management practices, but I don't pretend to think that the choices I make on my individual 200 square feet is going to have a huge impact on the environmental quality in Lincoln, Nebraska. But when we consider that recent estimates suggest that there's over 50 million vegetable gardeners in the US, collectively, all of those 100, 200, 300 square foot garden spaces, now we can have some collective impact if we're all following good practices. Okay, so that sets up why we did this work. So our objectives were to, one, benchmark soil health on urban farms and gardens in Nebraska, and then look at how the effects of historical and new management practices influence soil health. So a lot of the urban soil research in the literature has been done in places like Cleveland, Ohio, or Chicago, Detroit, Oakland, California, Boston, Massachusetts. We just don't have a lot of information from Nebraska, so that was part of our motivation and why NRCS was interested. And then we wanted to increase knowledge and adoption of soil health management practices in urban gardens and small farms across Nebraska. And so we just really wanted to get people trying these things. So we started out by recruiting participants. We settled on about 390 people across Nebraska. And this map kind of shows the distribution of where folks were coming from. And each of these participants committed to taking at least 100 square feet of their garden or small farm to implement a new soil health practice. And then they were going to collect and send us soil samples 3 times over 2 years. So time zero before they added their new soil health management practice, and then 12 and 24 months. And you can see in the image here, the two biggest circles are Lincoln and Omaha, so kind of southeast Nebraska is where most of the people in Nebraska live. But as we were recruiting participants, we got lots of emails from folks saying, "Hey, I live in Ashby, Nebraska. I don't typically consider this an urban area, but can I participate?" And when you look at their backyard garden, it looks very similar to those in Lincoln or Omaha. And so, absolutely, we took those people into the study. And so you can see that where we've got these ones, those are kind of those one-off folks that were maybe gardening on a homestead. So the 7 treatments that we looked at, we used kind of a cascading approach. So we had 4 treatments that were individual, so cover crops, no-till, compost, or biochar. And then we wanted to see if increasing the intensity of these practices by using 2, 3, or 4 of them stacked together would lead to different outcomes. And just as a quick aside, we did survey folks to ask why they were willing to sign up for this. They did receive free soil analyses for participating, and so a number of people noted that that was motivation for them. But I found it interesting that the majority of people that participated really just wanted to try or learn something new and participate in research. So just an interesting, if you're interested in citizen science, there's just lots of willing people out there who love to work with research and just be involved in that cutting edge work. But in terms of the soil, most people were interested in soil biological quality. So lots of excitement about microbes and what's below ground. Okay, so in we had these 390 participants across the state, and each of those was a data point. But we also knew that that was going to be a little bit messy and chaotic because we don't have too much control over what those folks do. We did our best to guide them on how to collect the soil and how to implement these management practices, but we did replicate all of these treatments on campus. We had a common crop that we would send seeds to people who were interested, zucchini, sweet corn, and broccoli in each of those years. On campus, we've got different entry points, so this was kind of like a crop rotation experiment. Okay, so over the course of these 24 months, we did 634 soil health analyses on participant soils. You'll see that 634 is not 390 times 3. So you can imagine that doing citizen science, you have some attrition, and we saw a decent drop off between time 0 and 12. We expect people got their free soil health test and maybe realized that it was a bit more work than what they had planned on committing to. So, but we ended up with about 150 people that stuck with us all the way until the end. All right, so the first bit of data that we got was just a benchmark of urban garden soils in Nebraska. So the first thing, these are all box whisker plots that I'll be showing you. And so the box in the middle is kind of the middle 50% of all the data points. And then the kind of error bars there represent the kind of maximum and minimum values. And then those little dots are considered outliers in our distribution. So you can see nitrates, soil nitrates, the kind of median value was right around 20, 25 parts per million. That's a little bit high for residual nitrate. Folks were taking these samples in the spring before they planted or added any amendments. So, we interpret that as that nitrogen is maybe a little bit leaky or inefficient in some of these soils. People might be over applying to some degree with their fertilizer or even through compost and manures. Soil phosphorus, I think Maggie mentioned that it was quite high in some of their samples. We found that if we're using 25 parts per million as a kind of common sufficiency level for a lot of our crops, about 98% of the soils we tested were above that. So you can see we saw some samples that had 2,000 parts per million or even 1,000 parts per million, so much higher than we'd expect. And this might be alarming if you were in a highly erodible rural soil, but a lot of these gardens we're not necessarily worried about sediment loss, so we're not really always worried about losing this phosphorus to waterways like we would be in a rural soil. pH of these soils, interestingly, was pretty high. So the median was about 7.6. And so some of that could be just the legacy of compost application, since compost runs a little bit alkaline. But also, we've got participants in western Nebraska where we have calcareous, more alkaline soils, and so that could be represented in this data as well. Our soil organic matter averaged 6.9%. So the soils that we tested, we can see there's some that were as high as 35%. We assume that those were probably raised bed, highly amended gardens, right, with a lot of compost mixed in. And then we did the CO2 burst test. Those were mostly average. And then very water stable aggregates. So about 85% on average for water stable aggregates. Anything above 50 for most soils is considered fairly stable. So again, not really highly erodible soils here. Okay. So compared to other states and cities, lead was less elevated in these Nebraska soils. So over 99% were below what Nebraska uses as the voluntary cleanup level of 400 parts per million. So I set on this graph here a line at 100. That's kind of a more recent, more conservative threshold for remediation used by the EPA. So 92% of our gardens fell below that. So just two gardens were in this area of concern around 600 and 800 parts per million. And then, as far as arsenic, we saw much more that were above the thresholds that we see. So, pulling this from a resource from Duke, they look at 16 parts per million as a threshold, and about 50% of our soils were above that threshold. And so you can access those resources if you're interested in, strategies. A lot of them are going to be similar for lead and other heavy metals, but adding compost and organic matter, and then just avoiding adding new arsenic. So poultry litter can sometimes be a source of arsenic, and then of course treated lumber. Okay, so a few other takeaways from our research. So most of what I'm going to show you is that data from our replicated campus trials. Oftentimes the trends in our participant soils were similar, but again, a lot of noise in that data because of all the different ways that people are managing that soil and the big range in textures and soil types. So similar trends, but just not as clear as what we found on campus. So we found that compost consistently increased our soil pH over the 24 months. So these top three lines going from 0 to 24 months are the three treatments that got compost. So compost alone, and then when we paired compost with no-till and landscape fabrics and cover crops, or with also that biochar. So we went from just below neutral, so maybe about 6.9 or 7, and it jumped to close to 7.6 in that 24-month period. We also found that compost consistently increased or at least maintained soil organic matter. So again, top three lines there are the treatments that got compost. We were starting with an already, excellent soil with organic matter around 4.6. And so the best case scenario that jumped to 5.2 within 24 months. And then in the other treatments, we saw a slight decline. We found that biochar increased sodium, and we assumed that this was possibly through adsorption from irrigation water. So in this case, those top two lines are the biochar alone treatment and biochar with the three other no-till cover crops and compost. So soil sodium jumped from 30 to 55 or 60 parts per million. We did see kind of this general increase in all the treatments, but it seemed to jump a little bit higher with biochar. So, one of the purported benefits of biochar is that it has high cation exchange capacity, so it can reduce leaching of things like potassium. It can bind those things in soil, and so it seems possible that that's what's happening here with sodium. We found that compost increased, but no-till with our landscape fabric decreased water-stable soil aggregates. So they kind of bounced around here on us, but you can see at the bottom here, we've got that no-till treatment. We've also got biochar, so that dropped us to around 65% water-stable aggregates. And then compare that to the top here, where we've got our no-till and compost and our four-way treatment. So it seems for whatever reason that using that landscape fabric seemed to reduce water stable aggregates. And again, compost seemed to help a little bit. All right, so in terms of yield, and you can kind of see what that landscape fabric looked like in this picture. And so this is our broccoli last summer. So we found that, generally and maybe not surprisingly, healthy soils, which we were starting with on campus, are less responsive to these soil health management practices in the short term. So we found that the yield of zucchini and sweet corn in the first 2 years were not affected by any of these management practices. And it wasn't until the third year when we grew this broccoli in this picture that we found, because it's a cool season crop, it seemed to really like the early season effects of that black landscape fabric. And so We saw a yield increase of 59% compared to treatments without that landscape fabric. So again, not necessarily a soil health related increase in yield, but just an associated management practice by using that soil warming benefit of the mulch. Okay, so some of our key takeaways about each soil health management practice. We found compost had positive, probably the most positive short-term soil health benefits related to soil nutrient cycling, carbon, and organic matter. As far as biochar and cover crops, we just weren't finding many changes in short-term soil health parameters that we were measuring. As far as no-till, we saw limited changes in soil health, but again, the benefits of mulching in terms of additional soil warming, weed suppression, and crop yield of at least one crop. And then again, looking at stacking practices, some additive benefits, but they were relatively minor compared to that kind of big hammer approach of compost. So important caveats, we did not include field measures of soil water infiltration, respiration, compaction. We didn't look at other important ecosystem services like pollinator activity associated with those cover crops. We weren't looking at erosion or nutrient leaching or volatilization. So the takeaway shouldn't be that these practices have no soil health value. It's just that the things that we measured in this short amount of time, we weren't picking up key differences. So again, this was funded through USDA NRCS through a conservation collaboration cooperative agreement. So many thanks to them. And if you want to learn more about our work and some of our other projects, that QR code should hopefully take you to our website. So thanks, everyone.
Awesome. Thank you, Sam. I'm assuming now's my time to jump in as a host to go through some Q&A with the speakers from today. And so there's a few questions in the chat. If you have other questions, not the chat, but the Q&A feature at the bottom of your screen. If you have other questions for Maggie or Sam, please drop them in the Q&A. There's a few questions for you, Maggie. Somebody anonymous asked, should we be looking for PFAS in urban environments? What do you think?
Yeah, so the general principles are the same. So you want to kind of think about your risk for that PFAS or PFOS contamination. So and I also will say too, you probably want, if you're concerned, you probably want to visit your state EPA website, because a lot of our states have done research into where some of these hotspots in our states are. They've tested rivers. So our PFAS are also known as forever chemicals. They break down readily and become in our water, therefore can be in our soil as well. So but so state EPA is the first place I would look to see if you can find a map of where they've identified some hotspots in your state. But then also just knowing a lot of our heavy contamination of PFAS happen around Air Force bases, actually, Air Force bases and airports in general, because some of the heavy contamination is actually due to the firefighting foam that has been used in past firefighting exercises at these Air Force bases where they're putting out jet fuel fires. Okay, so lots of other sources of contamination, but that's where we see these really big hotspots are in those types of areas. So if that sounds like an area that you might be in, it might be worth looking into. From what I know, though, the tests, the soil tests that test for PFAS are still very expensive. So I don't, if anyone has new information, if someone's doing that at a lower cost, so it could be difficult to test for, even if you are in an area where you think you should get tested.
Right.
But
thank you.
yeah. Mm-hmm.
There's a question from Tamara Brooks, and question is, for soil that is heavily compacted, can you use a no-dig method with heavy ground barrier to grow food?
Yeah, a lot of folks have been successful at kind of adding layers and kind of like growing up off the soil. So that can be done, whether it's in containers or just by layering material on top. That can be done. The first thing I would recommend is make sure that the material you're bringing in is also clean and not contaminated. Because I have heard horror stories of people bringing in truckloads of soil and then finding that they have a contamination issue in that purchased soil. So be careful of that. But then also, sometimes the issue you run into with the compacted soil is that if you're building up, whether it's in a raised bed, or just material on top, drainage is still going to be an issue. So if that site had pooling water already, then that kind of layering on top is probably not going to work for you because you're still going to have pooling water somewhere. And that also might cause erosion in a big rain event too. So unfortunately, building up does not solve the water drainage issue that you might have on that site.
A related question from someone else was asked, can raised beds reduce risk for contaminated areas? And if not, why not container gardening?
So in terms of raised beds, they can be a tool that can help you achieve that purpose. Again, the number one thing is whatever the material bringing in to fill that raised beds, you have to make sure that it's clean and free of contamination itself. The second way that it can help with contamination is that it outlines a small area in which you can actually dilute the soil that's below, right? So if you're just thinking about a container and if you have it half full, right, and that soil is contaminated, if you fill it by volume with another half, you're diluting what's in there by half, right? So OSU, we have a soil professor named Nick Basta. He's been doing a lot of research into low cost ways to manage lead soils with elevated lead. And that's one of the methods he suggests and has outlined is this kind of dilution method where you're adding clean material to actually dilute the soil. So the raised bed is perfect for that because you're choosing a small area where you're going to be able to dilute that soil to a safe level. You do have to consider how you're going to provide a ground cover for the rest of the site because you'd want to have grass or some kind of mulch to kind of remediate the other areas that you'll be visiting in the garden. And the second part of that question was container gardening. Container gardening is a great option. So people do this in a lot of different ways. I've seen a lot of high tunnels with grow bags, right? Where you can kind of bring in that clean material and kind of cycle out that grow material quickly too for kind of high value, high yield production. So container gardening is certainly an option.
I have one other question. Maybe it's more geared towards maybe the audience, just in case they don't know. So when you're talking about urban environments and lead, where do you typically see the greatest concentrations of lead in soils? If you're up
Yeah,
against a house or if you're away from the house?
absolutely. So like up against the house would be where you see the concentration, right? Because it's the lead contamination is usually from flaking paint that's fallen off the house over the years. So you will see that usually around the house, which is of concern because, right, if there's a house that needs, remediation, and is remediated so that the kids aren't being exposed inside or on the porch area, we don't want the children playing in the soils surrounding the house that can also be contaminated as well. So yeah, around the house, more difficult again to figure out where that house was if it's demolished. So if it is demolished, you want to test that whole frontage or that home demolished side of the parcel is what you want to test.
Awesome. Great. Great answer. Let's switch to Sam. And Sam, there's currently no questions for you in the Q&A, but I thought of a few for you. So I wonder about the landscape fabric idea is really, really interesting. Lots of people have used this for years. I'm wondering if you can say something about why you saw a decrease in aggregate stability using the landscape fabric.
I was worried somebody might ask about that, Jim. Yeah, it's a great question. We've kind of dug around in the literature to see if it's something to do with the elevated temperatures, or maybe it's the additional moisture that we get beneath that, because we are drip irrigating underneath that fabric, and so it could be related to some of that maybe excessive moisture paired with the higher temperatures and microbial activity. But when you go down one path, you find something that's contradictory on the other. So we're still not entirely sure why we were seeing that trend. But what's interesting is that was the strongest consistent trend that we had between campus and the participant gardens. So that same trend showed up even statistically significant in our participant gardens, which it was tough to find statistical significance in the participant gardens. But we saw that same drop in water stable aggregates below that landscape fabric. So yeah, it's something that we're still looking into, but haven't come up with a great kind of cause and effect yet.
Okay. It's just interesting. Maybe it doesn't really matter because you're in an urban environment and it's small and you have the soil covered, so the risk of erosion is relatively low. But it's just an interesting observation.
Yeah, unless you take it off, right? So just as an aside, we do a lot of work in our research team looking at bio-based and biodegradable mulches as alternatives to those plastic mulches. And depending on the material, a lot of those really shift the microbial community towards fungus, and particularly, saprophytic fungi. And so, um, my expectation is that, if you were to use a bio-based alternative, that might help to kind of counteract some of those reductions in water stable aggregates by building up that fungal community. So it could be an artifact of the type of material that we were using, but again, still looking into it.
Great, thanks. Manbeer, you have your hand up and then we'll go back online.
Let's take the question in the Q&A and then I'll ask mine.
Okay, perfect. So there's a question in the Q&A, and I'm not sure which one of you would like to answer this, but it states, can we get a nitrogen credit from clover, alfalfa, etc., cover crop? If so, how much and when?
Yeah, absolutely. Yeah, we typically say, for most legumes, it's about a 20 pounds of nitrogen per acre if it's just the residues from that legume as a previous crop. If you're using it as a cover crop, or even alfalfa that has been, you know, grown to a decent size before incorporating it, we might be able to take as much as 70 pounds of nitrogen per acre. And so when you would take that credit would be in the next crop. So if I'm growing cucumbers and the recommended nitrogen application rate is the equivalent of 140 pounds of nitrogen per acre scaled down to, 1,000 square feet or whatever you have, then I can cut my rate in half basically if I had tilled in alfalfa previously, or if I had a cover crop. Then a nitrogen fixing cover crop, you'd want to get an idea of how much biomass you had, so you could quickly go out and clip that and weigh it, and then you could use even just an estimation of nitrogen content of something like 3 or 4% by weight. And then you can calculate how much nitrogen you're getting. I'll promote the Oregon State University Small Farms website. They've got a nitrogen availability calculator that's great for different cover crops, compost, organic fertilizers. That'll give you an idea of how much of that nitrogen is going to be available at 4 weeks and at 10 weeks. So based on expected nitrogen mineralization curves. So yeah, that's what I would do.
See you shaking your head, Maggie.
Yeah, I don't have much to add. I think that was an excellent answer and far beyond what I could have, the detail I could provide. But just to give one more resource, since we are kind of focused on urban issues today, I think people in urban areas are really interested in cover crops, and there's growing, but not a lot of great information on how to do cover crops in small areas. But the Marion County in Indiana, soil and water has a really amazing site, and I'm forgetting the gentleman's name right now. I want to say Brian, but he just does such a great job at talking about cover crops in small spaces. And I know he has not something as easy to use as a calculator, but he's got a lot of cover crop seeding plans for small spaces that include a nitrogen credit concept in it. I've got the link, but I don't know if I can share it here or maybe when we follow up with folks.
There's a follow-up question about terminating alfalfa. When do we terminate the alfalfa to timely get the credit when the follow-up crop needs it?
Yeah, loaded question, but generally I would say the sooner that you terminate and incorporate, the faster it will mineralize. But there's trade-offs of that. So I wouldn't recommend tilling it in like the previous fall, because then you're going to lose some of that nitrogen to leaching and volatilization, and the soil's exposed. But 2 to 4 weeks before you're going to plant is safe in terms of you're going to start that mineralization, and you might not need to add additional fertilizer. But there's also benefits of waiting, right until you're ready to plant, or even planting into it and trying to terminate it after, in terms of the weed suppressive benefits and things like that. But kind of taking all that into account, I would say 2 weeks before you want to plant.
Yeah. What do you think, Maggie? I see you also shaking your head again. So
I defer to Sam on that. I'm not as well practiced with cover crops, so yeah.
perfect. Mamber, you had a question.
Um, Maybe Sam, if you want to share like your 2 cents on the usage of biochar, you didn't saw really big differences with its usage. Was that the rate issue or what was happening in that specific scenario?
Um, yeah, it's a good question. I don't think it's a rate issue. We were using a fairly high rate. I'd have to go back to look at the exact rate, but it's the kind of generational type of application rate, where your thinking is that you only need to apply once. Yeah, why we weren't seeing more benefits, I'm not sure, but there's a few other folks doing biochar research here that are seeing, I guess, similar things in terms of a lack of effect on yield. We I was fairly new to biochar, so I didn't have many expectations, I guess. But the sodium thing was interesting and made sense. We're also the one data I didn't share today was we're looking at organic matter fractionation work that Fernanda's familiar with. It's and she knows that it's very time consuming data to get, so we're still working on it. We expect that the benefits of the biochar might show up a little bit more there in terms of kind of early precursors of building organic matter in some of the smaller fractions of the soil aggregates. So we'll see. I'm not giving up yet on biochar, but in what we tested, we didn't see a lot of benefits.
Thanks.
There's one quick question in the chat, and then we'll wrap it up. So the last question is, what was the cost of the biochar, if you remember?
That's a great question. Ours was free because we got it through the city of Lincoln through a pilot program. But biochar is one of those things that, I mean, if you really want to get it, you can pay way too much for it, because a lot of it's such a high volume. It's very low bulk density, and so to get the application rates that are recommended, you have to put on so much of it. I mean, it's like a powder in some cases. So if you're getting it from California to Ohio, you're going to pay way too much because it's just freight that you're paying. Um, but if you can get some locally, if some cities have pilot programs to try turning down trees into biochar with like a small pyrolysis setup for at least testing. That's the way to do it, because otherwise it can be really expensive.
Awesome. Thank you. Fernanda, back to you.
All right. Thank you all for those great questions.